Springs are found in all sorts of different designs. Arguably, the most important characteristic of a spring is that it's elastic, meaning it's able to be stretched, bent, and compressed, but you can't really stretch components in SolidWorks. However, there are some ways to work around this limitation. I'd like to show you one way to create a customizable spring model that you can use in assemblies that will stretch and compress when you move it. Here I have a blank part file. I'll start a sketch on the front plane. I'll sketch a small circle off to the left of the origin. I'll add a dimension to the circle to control the thickness of the spring coils, and a dimension from the center of the circle to the origin to control the radius of the spring. I'll also create a horizontal relation between the center point of the circle and the origin. Finally, I'll create two sketch points which I'll be using later on as a reference. I'll add a symmetric relation between the points about the origin. I'll then drag one of the points so it's coincident with the center of the circle. And I can launch the revolve feature. I want to revolve this sketch 180 degrees, creating basically a half coil of the spring. Next, I'll need to create some axes to use as reference geometry. In order to do this, I'll have to show the sketch used to create the revolve with the points added. I'll launch the axis feature and select the end face of the spring and the sketch point. You can see the axis runs through the center of the stopping face on the half coil. I'll repeat this process for the other side, and I can now hide the sketch. With the axes created, I'll now add mate references to the part. For the primary reference entity, I'll choose the end face. This will be a coincident reference using the anti-aligned option. For the secondary reference, I'll choose the axis we just created, again choosing coincident, but this time the alignment can be any. I'll again repeat the process for the opposite side with the same settings. Now I can save the part. I'll call it half spring. With the part saved, I'll open and pin the design library and drag a copy of the half spring into it so I can access it quickly. I can now close the half spring part and start a new assembly. The Insert Component tool opens by default, but I'll cancel out of it. I'll use the Hide Show drop-down to show origins, and I'll drag and drop the half spring onto the origin, making sure the part's origin and assembly origin are coincident. Now I can continue to add the rest of the instances of the half spring to create the full model. Notice how because I set up mate references earlier, the half springs snap together as I add them. Move the mouse so that it snaps into the correct orientation. I'll continue adding instances until I have however many I need. I have the spring I'm looking for, and the mate references added most of the mates I needed for me, but I still have to create a few more mates to finish the assembly. I'll hide the origins and show planes. I'll also show the top plane from the first instance of the half spring, and you can see the planes appear for every instance of the component. The mates here are a little bit tricky to get the spring to behave the way we want it to. I'll launch the Mate tool and enable Multiple Mate mode. This will be a parallel mate. I'll start with all of the planes that are currently horizontal. The common reference here will be the top plane of the second instance of the half coil, and I'll add the mate to the rest of the planes on the way up. I'll repeat this for the other set of planes, this time with the second plane down being the common reference. So, by using the multiple mate mode, I've added mates to every plane here, except for the very top and very bottom. I'll close out multiple mate mode and add a parallel mate between the two planes. Finally, I'll add a coincident mate between the right plane of the assembly and the right plane of the last instance of the spring to stand it upright. That completes the model. I'll hide the planes. Notice I can simply click and drag the spring and it resizes. If you need a different size spring, all you need to do is change the dimensions used for the original revolve feature and perform a rebuild. You can change the diameter of the spring and also the thickness of the coils to accommodate whatever your design needs. One thing to keep in mind, though, is that while the model seems to behave like a spring, it's only mimicking the motion and not the physical characteristics of an actual spring. For example, if I compress it too much, however, you can see that the coils will interfere and overlap, which is physically impossible and something to look out for.